So you'll remember the Millikan experiment. Let me get this in here. Is it all yours or is it all mine? All yours. Sorry. I won't get it anyway. You'll remember the Millikan experiment. What was the purpose prior to the Millikan experiment? What was he trying to do? Remember? No? So wait, what was he trying to do? Find this charge on a single electron. And Jason, do you remember the number? What did he find out? Yeah, 1.6 times 10 to the minus 19 what? Coulombs. And what's an Elch? Elementary charge, which is equal to what, Colby? How many coulombs? 1.6 times 10 to the minus 19, right? So he found the charge on a single electron, elementary charge, or as I like to call, an Elch. So this first one here is going to be very similar to one that you've done already. So here we've got a small ball of mass, 6.5 times 10 to the minus 5 kilograms. Charge is 1.5 times 10 to the minus 10. It's suspended in air. Is that important?
Probably.
Because I asked?
Yeah.
Why is it important, though?
Because then
It means the forces are equal, right? In air above an electrically charged plate, what field strength is required to suspend this particle in the air? So we've got the mass, we've got the charge Q, and it's asking for field strength. We are solving for E. Oh, I have to do that again. Try again. Okay, so should we draw a picture?
No.
We don't need to, but it helps. I think it's good to remind students what's going on here. So our weight force, Fw, is equal to our electric force up. Vinny, it looks like to me like you're watching a video on your phone. Is that because you're watching a video on your phone?
No.
Oh, you're a good actor then. Oh, gotcha. Can we find the weight force? We can. It's equal to m times g. So that's going to be 6.5 times 10 to the minus 6 multiplied by minus 9.8. And I need to get a calculator. Oh, I left mine at home. Yes. Use this one. So 6.5 exponent 6 negative times 9.8. Put it in scientific mode. 6.37 times 10 to the minus 5. Does that make sense? A little bit of a trick here. You should know that this exponent here should always be one less than this one. Do you know why? Like this is minus 6, this is minus 5. Do you know why it's going to be only one away? Because you're basically multiplying by 10, which moves the decimal place, right? So in a very rare situation will it not be one less. So 6.37 times 10 to the minus 5, and I guess that's really negative, which means then that the electric force is positive 6.37 times 10 to the minus 5, right? Up. And we're asked to find the field strength, E. We did these questions already, right? Yeah. So let's get a little review. E equals F over Q. We're solving for the value of E. So 6.37, whoops, times 10 to the minus 5. The charge is 1.5 times 10 to the minus 10. Now, that number should still be in your calculator. You shouldn't have to clear it or anything. It should still be there. 6.37 times 10 to the minus 5. We're going to divide by 1.5 exponent 10. Negative. Well, I get a big number. 4.25, we'll say, times 10 to the 5. And that's going to be electric field strength. That's going to be newtons per coulomb. Okay, well, let's try this one. The first two are almost virtually the same as the ones we did the other day. Here we got another one with a mass. Suspended in midair. That's key again, because that means that the forces are balanced. Usually at this point someone says, will the forces ever not be balanced, Mr. Bennett?
Well, of course they're not.
Good question, Jason. They will be, coming up in the very near future. What's going to happen when the forces aren't balanced? No. There's going to be when the net force is not zero, there's going to be an acceleration. Coming soon to a theater near you. Like tomorrow. Maybe the next day. At the point in the air, the electric field is 300. This is our E. Now we're asking for the charge. So same steps, except for that last little bit, right? Do I need the picture? The picture really just reinforces the idea that the FW is equal to the E, to the FE, right? Now, how about if you did this, but everything else was completely wrong? Do you think I might give you something? I would probably give you something. You know at least that these are equal forces. Okay? So it wouldn't hurt to draw the diagram. Okay, let's find our weight force. Mass times gravity. 7.0 times 10 to the minus 8 times minus 9.8. .86 times 10 to the minus 7. Do I really need to write this next step, do you think? It's kind of like that diagram, like if you don't have it but you know what's going on, I mean, you're going to get full marks. But if you're having trouble, if I'm kind of looking for marks, something like that would be more convincing to me that you know something. E equals FE over Q. The electric field is 300. The FE is 6.86 times 10 to the minus 7. And we're solving for Q. Now we've had lots of questions like this where the unknown's on the bottom. You need to be able to solve this. So that's going to be 6.86 times 10 to the minus 7 divided by 300, right? Those guys just switch places. You should still have that number in your calculator. All you do is just go divide by 300. .3 times 10 to the minus 9. And that's measured in coulombs. What if the question asks for the charge in Elches, in elementary charges, or electrons? What do you do? Well, if you like, you can set up a ratio, and I showed you a little bit about this before. I always say that one of the math skills that you should have learned or that you actually use in life is ratio and proportion from about grade 7 or 8. So you could say that one elementary charge is the same as 1.6. We'll just say 1.6 times 10 to the minus 19. So how many x Elches is 2.3 times 10 to the minus 9? Right, set up a ratio, and I think you'll discover that you end up, you cross multiply, so you get 1.6 times 10 to the minus 19, x, right, cross multiply is equal to 1 times that. You end up doing a whole lot of writing. Basically all you're doing is dividing by 2.3 times 10 to the minus 9. You are dividing by 1.6 times 10 to the minus 19. Right?
Just right up all those steps, you just show your...
You can just show the dividing. But you got to know that it's dividing, because sometimes you're going to have to go from Elches to coulombs, and that's when you're going to multiply. So you're going to take that number again, it's still in your calculator, and you're going to divide by 1.6 exponent 19. And I get 1.4 times 10 to the 10. That's a lot of electrons. 1.4 times 10 to the 10. It's got a lot of charge. And that is Elches, or if you want, electrons. That would be one more step, right? That would be like a third mark kind of thing. Okay, so that's been the warm-up. Is it hot in here, or is it just me? It's hot in here? Okay. Here's where it's going to get a little ugly. You should notice that this example's on a new page. You've got the entire page. You're going to fill that whole page. If you're a big writer, write a little smaller. I think it's 6 steps long. Okay? Okay. We have an oil droplet that has a radius of 0.0006 centimeters located in the Millikan apparatus. It is suspended in midair above a 0.3 Newton per coulomb electric field. The density of oil is 800. Determine the charge of the droplet in coulombs. Oh. What's different about this one? It's got a radius and density. But really, we had the electric field before, right? Before I had the electric field, I had the mass. So I have to go from radius and density to mass to make this work. Now the reason I do this is because, Millikan actually had to go like terminal velocity. He had to do some calculations before he got to the mass. So I'm simulating that with these couple of steps. So you have a better idea of just how many steps he had to go through to come up with the charge on one drop. Okay? Let's get a little exercise in math here as well. Okay. So I'm just going to give it to you. You have to find the volume of an oil droplet. Does anyone know what the formula for the volume of a sphere is? You know, just on the top of your head. Well, it's a three-dimensional volume, right? If you're ever on a game show and you get asked this question and you have phone a friend, I am available. Okay? I'll take about a 10% cut of whatever your winnings are. Would you call me, Colby, if you were on a game show?
No.
You wouldn't.
Well, if you're taking part of the money, I wouldn't.
You're going to call someone else that's not going to know the answer, because you know I'm going to know the answer.
I know the volume for a sphere.
Do you know what it is? Did you Google it?
It's 4 or 5 times.
You're right.
Sometimes
Oh. Nice. Well done. 4/3 pi r cubed. I like it. Does it say on yours? Does it say 4 pi r cubed over 3?
Yeah.
Yeah, same thing, right? 4/3 pi r cubed. Okay, so we got to know the radius. Now I'm going to tell you this right away. Watch for the word radius, because every once in a while, someone that makes up questions, he's a real jerk, likes to throw the word diameter in. Can't even say it. Diameter. How do you get radius from diameter? Divide by 2. Also notice that this one is in centimeters. So you're going to have to convert that to meters. So you need the radius in meters before you can begin.
Why? Oh.
Because the density is kilograms per cubic meter. So, my friends, about grade, I don't know, it used to be grade 6-ish. How do we convert centimeters to meters? Yeah, you do. You just divide by 100. Centi means 100. How many cents in a dollar? 100. That's why they're called cents, because there's 100 of them. So you're going to take that 0.006, which is a radius, and before we do this, you're going to have to divide by 100. Okay? So the radius is going to be 0.0006 divided by 100, and express that inside of your notation. Six times 10 to the minus 6. You're going to have to take your time here. Here's where all those rules that I've been fighting with some of you about organizing your work and setting everything up are going to come into play, because this is the biggest question you're going to see. Take your time. Okay, so volume is going to be 4/3 pi times 6 times 10 to the minus 6 cubed. Try it on your calculator. Do you know how to do cubes on your calculator? What's that? Some of you will have a cube button. Some of you won't. Some of you will have to use this button here to the power of 3. Right? Some of you will have an x to the y or a y to the x that you'll have to use. So let's just try that. So I'm going to go on my calculator, I'm going to go 4 divided by 3 times, now you should use the pi button that many of you will have, that I can't seem to find on this one. There it is. 4/3 times pi times 6 exponent 6 negative to the power of 3. And make sure you hit equals. You're going to get a really tiny number. I get 9.05 times 10 to the minus 16. Now, I can always tell when you forgot to divide by 100 because you're going to be off here by 6. If you got times 10 to the minus 10, I know you didn't divide by 100. Because you're going to have a minus 4 there, and minus 4 cubed is going to give you minus 10. Okay? Here's where showing your work is really important because I will follow through. If you're doing the right steps, I will give you credit. If all you do is forget to divide by 100, half mark off, no big deal. If you show your work. So that's 9.05 times 10 to the minus 16, and that is in cubic meters. Now, I don't expect you to have to put units on every one, but I'm just going to do it for the sake of completion here, just so that, if you're looking back at this, you can see what's going on. Okay, so that is the volume. Now, think way, way, way back to September when I first reviewed graphing with you, and we talked about the slope of a line equaling the, anybody remember? Starts with a D. Density. See how things keep coming back? It's kind of like the circle of life a little bit. Circle of physics. Anybody remember what the formula for density is? Density is equal to mass over volume, which is exactly why I gave you the density, which is 800. You're going to solve for mass, and if I only had the volume, 9.05 times 10 to the minus 16. So you're basically going to take that number, which should still be in your calculator, don't clear it, and you're going to multiply by 800, aren't you? Right? You're going to take this value, you're going to multiply by 800. And I get 7.24 times 10 to the minus 13 kilograms. And I've now successfully converted a radius to a kilogram, a mass. And now that I've got mass, I'm basically at the same point that this question started at, right? I've just basically taken this question and gone back 2 steps. I got my mass. Next step is to do what? Find the weight. I told you to make sure you're well rested and well caffeinated for this morning. 7.24 times 10 to the minus 13 times minus 9.8. You should still have 7.24 times 10 to the minus 13 in your calculator. Still there, hasn't been cleared. Times by 9.8. 7.09 times 10 to the minus 12. And that's going to be a negative, right? Down. Okay. I already got my whiteboard. Some of you might like to start numbering these steps. I don't know. So after you got the wave force, then you're going to get the electric force is equal to the same value, just up. And we got to solve for the charge of the droplet. Electric field is 0.3. So step 4, E equals Fe over Q. Electric field strength is 0.3. Mm, 7.09 times 10 to the minus 12 divided by Q. We're going to take that number, we're going to divide by 0.3. That number should still be in your calculator. The beauty of the Millikan, all these questions, is you never have to clear and re-enter your calculator. It's awesome. It actually makes my job a lot easier. I can follow your steps because I just follow I can punch it all in at once kind of thing. So you take that number that you still have in your calculator, and you're going to divide by 0.3. 2.36 times 10 to the minus 11, and that's in coulombs. And is that our final step? So the term of the charge of the drop in coulombs. How would you do it if it said it in Elches? Exactly, right? If you wanted it in Elches, you just take that. It doesn't ask for it here, but just as a refresher. .5 times 10 to the 8 elementary charge. Let's just see here. You would get.
What did you get 5 for the converting?
I'd have to give you a mark for that because I would deduct if you didn't do it. All right. So that's a pretty nice, easy beginner mark. 2, 3, 4, 5 if you left it in coulombs, 6 if you went to Elches. If I make you take the diameter and divide by 2, then I usually make these a half each.
Would you get an extra mark for each Elches?
No, it doesn't ask for it, but I just wanted to refresh. It didn't ask for this, right? But if you had to do it, then that's how you do it. How much paper did it take?
Half a page.
Half a page? Okay. So I think I handed out some questions there, did I not? Here it is. The formulas are there. That's for, cool, we got the formula. There's Millikan there. You can put a mustache on if you get mad at it because you don't make you do those stuff. There's 7 questions. They start off easy, they get a little bit harder. Answers are at the bottom, link to the solutions. Have a great time doing Millikan. You're welcome. I honestly hope you enjoy it. Yes, Alana. Okay.